following podcast is for informational purposes only. The contents of this podcast do not constitute tax, legal, or investment advice. Take responsibility for your own decisions, consult with the proper professionals, and do your own research.
Hey IQers, this is GRTiQ. Recently, we've been adding transcripts to every release of the podcast, and we're also going back in time and adding transcripts to prior episodes. So if you're a longtime listener of the podcast or just getting started, be sure to visit grtiq.com/podcast for transcripts for today's episode and all the great ones that came before it.
Roger that.
One of the things that we must preserve as we go down the scalability path is the decentralization properties that we have from single chains, right? Like the problem statement here is preserve the decentralization of applications in a more scalable context. And so it's very exciting to have something like a graph as a decentralized network that's providing some of these indexing services.
We are like astronauts, floating in the space of time, lost between past and future.
Welcome to the GRTiQ podcast. Today I'm speaking with Ben Jones, director at the Optimism Foundation and one of the co-founders behind Optimism, a fast, stable, and scalable L2 blockchain built by Ethereum developers for Ethereum developers. You've likely seen Ben speaking or presenting at hackathons or conferences. He's got a unique approach that's equal parts down to earth, high energy, and brilliant. During this interview, Ben and I discuss his background and how he eventually made his way into Web3. We then talk about the origins of optimism, and I would dare say, Ben offers one of the best introductions and explanations of what L2s are and how they work. It's super impressive. Along the way, Ben shares his ideas about entrepreneurship, the future of the industry, the launch of Coinbase's Base, which was built on the OP stack, and the graph. As always, we started the discussion talking about Ben's educational background.
You know, my education started really rooted in math and science. Like growing up, I was super into that. And I also had some really influential, strong teachers that I feel lucky enough gave me a love of those sorts of, technical problem solving challenges as opposed to a hatred for the monotony of multiple choice quizzes and the like. But moving beyond that, I went to Northeastern University for college and I got a bachelor's in physics and math. I quickly found that the academic life was not the one that I wanted to do. Around the same time, I caught the crypto bug, went down the rabbit hole, whatever, little euphemism you want to use for saying became obsessed and couldn't think about anything else. So at the end of my education, I basically said, that was great. I learned a lot of good things, but I'm not doing academia. I'm doing something else. And here I am.
So what were you like as a kid growing up? I mean, what were some of the things you were into, some of the hobbies or interests?
So I feel like my first interactions with like programming, for example, was actually due to Lego. Lego had this incredible kit that they called Mindstorms, which was basically like a really probably extremely antiquated at this point, but basically like a microcontroller in a Lego box. And you could use it to program motors and sensors and kind of hook them up to each other. And it was all like a graphical kind of drag and drop interface. But that was my earliest exposure and one of my most beloved toys for a number of years.
That skill of putting things together, taking things apart, does that play well for people that decide to take a career in technology and programming and in Web3?
I dare say that the modularity thesis of crypto is literally Lego analogy written all over it. So I would say so. I think that really these things are what you make them, right? And so for me, like, for instance, the number one robot that I tried to build out of my Lego was a robot to clean up my Legos, which I was never very successful at. But I think it's certainly that there's certainly some, analogy drawn there where programmers love to automate things that they do. And so I feel like, there's definitely a lot of overlap.
Well, Ben, you're not the first guests of the podcast who has a strong background in physics and mathematics. I'm starting to see a reoccurring theme. Do you remember what it was about those two disciplines that drew your interest? Was this something that you were just naturally good at?
Yeah, I mean, I definitely have a huge amount of thanks to my parents for identifying that these were things that I were interested in and really leaning into that when I was young. I was fortunate enough to have my dad tutor me in math at a young age to like kind of scratch the itch that I wasn't getting, out of the elementary school guess and check approaches and that kind of thing. Yeah, so I would say I was fortunate enough to have parents that really tried to emphasize that, but I think they saw a natural tendency that I had and just were fortunate enough to be able to lean into that. It definitely wasn't shoved down my throat. I think that helped.
And when did technology become part of your personal story? So you're working on mathematics and physics. You're clearly a smart person that has some personal interest, but eventually you get exposed to technology and this becomes an important theme in your life.
I would say, tech always had interested me a lot. I built the gaming rig when I was growing up. And honestly, my biggest real exposure to programming, sure, I did this Lego block drag and drop thing, right? But my real first exposure to programming in a meaningful capacity of like actually writing text, I certainly wouldn't call it very meaningful, but I learned what the heck it was at least, was through actually game modding. I was really into like extending video games in different ways. And there's one game in particular that had a really active community that I really just fell in love with. I would say that for me, ultimately, the technology came after the realization of the importance of it in the crypto space, quite frankly. Like for me, it was not, oh, I want to get into tech, let me go and find crypto. It was, oh my God, that Bitcoin thing that I learned about a few years ago has been evolved into a new form of programmable world computer, insert blockchain buzzword here. And once that clicked, that was what drew me into the tech, and like the social and, economic implications of that. I think as opposed to, I wanted to go into tech generically and I found, crypto as the hot new venue to do that. For me, it was honestly very much led by crypto.
So let's then go pick up your story. You talked a little bit about what you studied at university. You decided you didn't want to pursue a career in academia. What did you do after you graduated? What did you do professionally?
Yeah, so I spent a bit of time actually working at a venture capital firm in Boston right after I graduated. I'd spent some time working there before I graduated and continued that for a bit after I graduated. But that was sort of something that I immediately transitioned into crypto from. And so my first work there was working at the Ethereum Foundation, actually not even on programming, but on game theory. So this was in the earlier stages of proof of stake. And we were basically working on building out simplified models to describe things like the fisherman's dilemma, which I wasn't super familiar with at the time, but is sort of the core problem of quote unquote data availability, which things like, the ETH2 beacon chain solve for. And so that was how it started. Was I went to the Ethereum Foundation, and through that, through those social circles, I met my co-founders, and not long after, Optimism started to be conceived.
How would you describe to somebody what studying and researching game theory means?
Ooh, that's a good question. And certainly there's some experts that can give a much better answer than I could. But yeah, I'll take a stab. I think in layman's terms, ultimately what game theory is about is expressing a formalized model, like a very specific kind of rigorous definition of what a quote unquote game is, which ultimately really could mean anything, but usually it has the notion of some number of players that are basically making moves and some sort of state transition function that describes what happens to the game when different players make moves. And so I would say that game theory is basically about formalizing different games, which again can be kind of arbitrary. Like you can, imagine most things as a game actually. And from there, basically analyzing the different properties or things called strategies for those players. So basically given that you have some game, given that you make some assumptions about the players, what are going to be the outcomes that we expect? What are going to be the quote equilibria? In other words, is there a winning strategy, right? These kinds of buzzwords. So I don't know. Yeah, like I said, there's some game theorists that would dunk all over that definition, probably. But at its core, it's about defining rigorously games that people can play, and then thinking through the consequences of what different players playing in different ways mean for the other players and mean for the game, and so on and so forth.
So after university, you find yourself in a VC. You're working as a blockchain associate. Are you using this degree in physics and mathematics every day, or is that a place where you're having to develop new skills and new understanding?
Yeah, definitely a lot of new skills required as I transitioned into crypto. I would say that my time at Underscore, I was very, very, very fortunate to be able to just learn a lot. This was during a period of time in 2017 and 2018 where the amount of new ideas and exciting things was just at an inflection point. It also spanned the last bear market, basically, where there's a big market crash around that time. And so I was fortunate enough to be exposed to all of the excitement and upside of the bull market. But then I was able to kind of like be left with the higher signal people, because it was clear that the people who had stuck around after the big market crash were in it for the right reasons. So yeah, I would say that I learned a lot about what was going on in the bull market. And then I learned a lot about what was staying around in the bear market. And to that, I sort of, learned to just love the industry that much more.
Well, that's another common thread. And it's this story of joining during a bull and then going through the experience of a bear is interesting to me. And partly because people don't leave. And so I want to ask you, why not just leave and go back to traditional work and professional track and avoid this type of cycle?
Oh, yeah. I mean, pick the euphemism you want. I said before, go down the rabbit hole, caught the bug, however you want to call it. I mean, I was just hooked by that point. I think maybe to even give it a more personal story, I was doing a study abroad program in Europe before I worked at the VC. And this was the point in time in which I basically literally met someone at a bar, was like, have you heard of this Ethereum thing? And I was like, oh, kind of heard the name. I know how Bitcoin works. And he was like, oh, take a look at Ethereum. It's picking up the pieces of Bitcoin and doing something even more powerful with them. And quite frankly, from that moment on, I read the Ethereum white paper on a bus in Italy or something like this. And from that point on, I was just hooked. It was very clear to me that the writing was on the wall, that this was going to be a game-changing tech. And yeah, there was just no looking back. There was no way I was going to back down just because, there's a bear market. If anything, from my perception, really what happened was I found myself going to meetups, and all of the cool people that I really enjoyed talking to were all still there. And a bunch of people that were joining that were clearly in it just for a bit of a manic craze, not really understanding the deepest parts of what was going on, were no longer there. So if anything, it was kind of a blessing in disguise.
So Ben, take us back, if you don't mind, to, I think you said being on a bus or a bar in Italy and coming across Ethereum and reading that white paper. What do you see? What are these aha trigger or these things that you identify that signals to you, this is something special and I need to get more involved?
Yeah, I think it ultimately boils down to the statefulness of Ethereum, or the extensibility, So I think zooming out, my first exposure to crypto was actually many years prior. I had started doing poker nights with my friends, and I was not of the age that I could play poker online, but I was very interested in that idea. And I discovered that there was a way to use this digital currency I had seen on Reddit to go and do that. And that was Bitcoin. And, I was really, really, really excited when I learned about that. And I was really happy to lose, money to people playing poker online for Bitcoin. Right. But at some point in time, I kind of tucked it away as the libertarian digital gold experiment. And I was like, okay, this is cool. I've followed the Reddit, but it doesn't seem like the thing that I want to devote my career to. Reading Ethereum, what you come to understand, a lot of people say that Turing completeness is the key unlock of Ethereum. I think the real intuition that is being driven at there is useful. But when you really look at it, the fundamental thing that you have is statefulness and persistence. So you could actually build a lot of what you could build on Ethereum on Bitcoin if you had something in Bitcoin called a covenant, which is basically the notion in Bitcoin that Bitcoin script, which is the programming language for Bitcoin, it basically can only return true or false whether or not some funds have been unlocked and sort of spent. What it cannot do is basically, as funds are moving, with all of those transitions of funds, it cannot hold on to a programmable bit of state that it basically can preserve as a history and read and write to. So ultimately for me, what it was, oh my goodness, this technology that is being built, that was built for Bitcoin, now can basically be used for arbitrary computer programs. And to me, the real thing that sold it was, oh my goodness, was basically, it's DAOs effectively, right? But more generally, it's just the notion that, oh my God, you can write a computer program that has the guarantees of the Bitcoin blockchain, but it can take actions fully autonomously based on the rules of a computer program. So to me, that was like the big unlock moment, was when I basically read that, internalized it. And then the Ethereum white paper just has like lists through a bunch of examples of crazy stuff you can build. And everyone was like, oh my God, that is so cool. That is so cool. That is so cool. And whether or not that list of use cases is the exact right one that ends up, landing crypto in the hands of a billion people, who knows? But to me, that was the unlock moment that went, oh my God, we can write computer programs that can hold assets and programmatically, input and release them. And so, yeah, that was the thing that sold me on it.
Ben, as you may or may not know, a lot of my listeners are looking for ways to get more involved in Web3 and to meet people and network. And I think they'd be interested to know the story about how you got involved with the Ethereum Foundation. What was the storyline and how did you get an introduction there and go to work on those things?
Yeah, I would say that another skill I definitely learned in the VC world, honestly, was like networking and socializing. So I met people a few times, basically just at crypto events. I mean, that would be my number one advice, is like go to the meetups and talk to people. Like that was how it all started with me. I met one person at the EF at one conference. I met them and a few others at a subsequent conference. We built relationships, realized that there was exciting things for us to do, and went and did those things. So yeah, ultimately my advice is just get out there and talk to people. I will also say that having had a number of years since I went through that experience, I suspect that it's even a better state today, because realistically, like at the point in time when I was joining Ethereum, the skill level for doing something as simple as writing a smart contract was just a higher bar than we have now. And that really comes down to tooling. It's been truly incredible to see the amount of tool. I mean, the graph is an example of this, right? But just across the board, even for something as simple as writing and deploying a smart contract, like there are now consistent tutorials that work for multiple months at a time. Whereas, there was a lot of these things where it's like, oh, this tutorial is 3 months old. Well, I guess my Web3.js version is broken. It's not going to work anymore. So yeah, I guess the only thing I would build on that is to basically say, also probably getting your hands dirty is a lot easier than it was a few years ago. And if you're looking for something to use as a way to talk to those people that isn't just, hi, I'm interested in learning about X, I think like the appetite is there. So go try to build something weird, get GPT to poop out some Solidity code that may or may not work, and then go talk to someone about it.
You talk about the evolution of the industry since you joined. So you said there, there's more tools and resources available now than there was at that time. When you zoom out and think about where we are in the growth and adoption of this space, how are you thinking about it? I mean, are we taking giant leaps forward? Have we hit some friction with regulation? How are you making sense of all of that?
So from the opposite perspective, it's definitely about darn time to turn our eyes towards like global scalability and global adoption. And there are a few elements to talk about there. 100% what I was saying about the tooling is true. There's no question now that there's a ways to go. And I think we're going to see over the next decade, tons more innovation on things like application development frameworks and in a multi-chain context, especially because right now the real transition that we're going through is a transition from one Ethereum mainnet chain that is, quite frankly, not in demand enough to beget any issues, to one in which the Ethereum chain has a lot of demand and the transaction fees are going up as a result. And we need to go to multiple chains to solve that problem. So obviously I can give the whole spiel of what Optimism is, this is scaling and what roll-ups do, et cetera, et cetera. We're building towards this thing we call the super chain. But I'd say ultimately, like we're at least moving through the next phase where we are really going multi-chain in earnest. And so I do think that the exact tooling circumstances I was talking about, 5 years ago are still challenges for going multi-chain, right? I think we've gotten really good at single chain tooling. There are lots of really, 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 really good options for developers now. I think we're at a similarly early stage of incompatibility and unstandardization and missing tooling for building applications that span multiple chains. And ultimately, to hit the global adoption, that is just something that we have to do. We have to be in a world in which there are multiple chains. And we have to be in a world further where users, for example, have no idea about those multiple chains under the hood. It's just the new internet that they are using, right? And so we're definitely not there yet, but we're taking the big next step. And I think we're going to see a lot of growth over the next few years.
So Ben, if we jump back in then to your story arc here and the trajectory that you're on, eventually you found Plasma Group. Can you take us back in time and just tell us a little bit about that story?
So ultimately, over my time at the Ethereum Foundation, it became quickly apparent that scalability was the hot topic on the people's minds who were looking far out. There was a class of people that understood that effectively everything that I just said about going multi-chain and Ethereum is going to get expensive when it gets congested was understood. And there were a group of people working on those problems. And those were one, incredibly compelling problems because they're incredibly fun. The design space is quite large and the goals are quite lofty, right? So there are a lot of fun things going on there, but they're also very, 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 very hard problems. So at the time, the zeitgeist that was basically the precursor to rollups, ironically, they're coming back. But before the rollup, there was the thing called Plasma. And basically, Plasma was very similar to the scaling solutions we see today, as in the notion was you create some other chain, some layer 2 chain, quote unquote, that leverages the security of a layer 1 chain like Ethereum mainnet, but affords cheaper transactions and higher throughput, sort of on top. So Plasma was the initial sort of work being done there. At the time, the complexity basically had not been properly split out is effectively what I would say. So actually, like, rollups are a much simpler design than Plasmas. And we just didn't know the constituent parts of those designs to be able to point at the smaller set and say, this is a rollup. It works better and is more easy to implement. And we're going to do that first. So at the time, the scalability landscape, it was clear that it was a pressing issue. So a lot of smart people working on it. We were having really fun working on these problems. But it was also earlier on in our understanding of these scalability designs. But that is where we started. So yeah, eventually myself and Carl Flourish and Jinglan Wang came together and we realized that we'd been, basically found ourselves after every conference and event talking about these problems and trying to figure out how we were going to scale. And we also saw a bunch of teams building out these Plasma designs, but it was clear that more research was needed to be done, right? Like I said, we didn't know the right boxes to put the different components into and say, this part is kind of like a roll-up and then Plasma is an extension that works in this way. It's extra optimistic properties on top. But ultimately, we knew that it was an issue and there was clearly a lot of research and development that was going to go on. What we also saw was basically a tragedy of the commons where there was no single central place where people were working on those fundamental designs for everyone to share. So there were quite a few teams working on building out their Plasma chains, but there was nobody really outside of the scope of those particular teams and projects and communities. There was nobody just trying to build out the best darn implementation and designs that we could. So Plasma Group was born. We founded a nonprofit called Plasma Group, and we raised grant funding for about a year of that. And based on what we did was we released open source designs, specifications, and code as public goods that would basically, we hoped, form the basis for the future scalability designs of many, many, many people in the ecosystem.
The GRTiQ podcast is made possible by a generous grant from the Graph Foundation. The Graph Grants program provides support for protocol infrastructure, tooling, dApps, subgraphs, and community building efforts. Learn more at thegraph.foundation. That's thegraph.foundation.
Hi, this is GRTiQ, and thank you for listening. Listeners who enjoy this content can help support the GRTiQ podcast by leaving a review or a 5-star rating wherever they download podcasts, by sharing episodes on social media, or by simply telling a friend or colleague about something they heard or learned from one of our guests. It's support from listeners like you that make it possible for us to keep shining a light on the people and stories behind Web3 and the Graph.
Roger that.
For listeners that are non-technical and may not understand this issue of scalability, do you mind just double-clicking on that? And I think part of the reason I want to ask the question is you're clearly an expert on this and have done a lot of deep work on it, but there's all these other type of problems that keep coming up. What is it about the nature of scalability that really needs to be addressed here? Why is this a going concern?
Yeah, let me try to break it down in really simple terms. Ultimately, scalability is a term that comes from and has a specific definition in the Web 2 world, right? And basically, the broadest sense of like architectural scalability for technology is just to say, okay, when apps go viral, how do the computers support increases in that load, right? So, there's countless examples of this, right? Like the history of Facebook, like Facebook almost failed because it was built initially on a framework called PHP. If you remember going to a .php forum in the olden days, PHP was the hot thing, right? But it didn't scale. So as Facebook started going viral and reaching millions and millions of users, their like server costs were a huge problem, right? That is an example of a scalability problem. And so, when you really break that down, that problem to its essence, right? Like what you see is that this software is being run on computers, and one computer, has some processor in it that is only so powerful. So if you want to handle millions of users, you have to distribute the program and run it on multiple computers at once, right? That's sort of like that's sort of a key part of the problem statement. So that's just like scalability in general, right? What about blockchain scalability? Well, you can think of a blockchain as a very unique kind of computer. It's kind of like this computer in the trustless, decentralized cloud, right? So we have this notion of a consensus algorithm, right? Like proof of work and proof of stake are these buzzwords that you'll hear thrown around there. But ultimately, basically what it means is that the rules of this computer are such that a decentralized network of nodes will come to agreement on the next step in the program, basically, right? And that next step is the updates to the decentralized ledger. It is the next block in the blockchain. And so basically, when we talk about blockchain scalability, what we talk about is applying the same problems of how do we handle a massive amount of load, but applied to this particular form of computer, which is not just some server in a warehouse somewhere, but is this blockchain thing. So that's sort of the key setup to the problem. Why is this difficult? So there's a very important difference between these systems like what Facebook is running and the decentralized systems like Ethereum, right? Where basically Facebook is just a centralized entity, right? That can route facebook.com/whatever to any computers that they want, right? And, this is like the cloud. And basically, as long as they can write a computer program that, for example, routes a user trying to get their Facebook feed from the United States versus someone trying to get that in Europe, they basically say, oh, well, we've got some servers over here and we've got some servers in Europe, and that we write a program for them to talk to each other if there's a post that is intersecting with both of those geographies, and so on and so forth. But fundamentally, there's a problem statement that's a lot harder in crypto, because in crypto, there's a decentralized network, right? There's not just some single entity that can point Facebook.com to a new, more scalable architecture that uses a bunch of computers in a warehouse that they own or that they're renting out from somebody else who owns a warehouse like Amazon or whatever, right? So that is the problem statement. How do we do the things that are the solutions to scalability that we see in Web 2? But how do we do that without sacrificing all of the decentralized properties of a blockchain? So that kind of zooming out is maybe the problem statement of scalability. Does that make sense?
Makes perfect sense. And I really appreciate that overview. So you're working on this early on. You're at Plasma Group. You're talking about plasma chains, which I'm understanding is like precursors to roll-ups and all the cool things that we're seeing now. When do then the seeds of optimism and making a more formal move on this problem start to sprout? And what was the context at that time?
The seeds basically started forming on day zero, I would say, especially in terms of a very important, key tenet of the Optimism ecosystem, which is public goods funding. I talked about, Jing and Carl, my co-founders, and finding a group of people that were really excited at working on these problems. We were also a little bit crazy, all things considered. We created a nonprofit. We went to these organizations and projects and tried to fundraise, and we did have some success there, enough to keep food in our bellies for the next year. But it wasn't the case that we could get the funding, and certainly not the security, to really employ larger teams of people. And that for the first year was okay, because we were the ones that were living with those trade-offs and taking the risk of running this weird, wacky nonprofit. And it really made it clear to us that public goods funding was an issue, because we could see all of the projects that were building plasmas looking at our designs, which was the whole point of what we were doing, and realizing that they could be used to improve their designs. And so they were incorporating that, and so on and so forth. But ultimately, if we wanted to take it to the next level, it was clear that kind of like trickling in donations and us three kind of YOLOing our belief that this was a good idea and that we could take the risk, being youngins, that ultimately wasn't going to last. And so the seeds of public goods funding were immediately planted, which would form basically one of the key pillars of Optimism's approach today. So that was the first seed. The other seed was realizing that we were at a point in time in which having more resources and having more people who were taking this more seriously was actually going to be useful, right? In other words, we started to realize those separations and I guess the better word is abstractions. We were starting to realize the core abstractions and features that went into building scalable blockchains. So you mentioned that Plasma was a precursor to rollups effectively. Spiritually, that is 100% true. Ironically, actually though, Plasma is more complex and sort of like basically requires, if you build things the right way, adding additional features to a rollup. And this was something that we didn't understand. At the time, it was just one big black box of Plasma. So the other big thing that happened was as we gained better intuitions for the abstractions that were involved in blockchain scaling, we started to understand that there was a thing on the horizon called the optimistic rollup that was going to be a lot more accessible, a lot easier to build, and was going to provide the kind of developer experience that was going to be able to actually get traction and no longer kind of be like this hypothetical research problem. Like this was a real thing. So that was the thing that really birthed Optimism was we saw nobody was funding these public goods that we were working on. And we said, okay, this needs to have a solution. We also saw that we were right on the cusp of having a solution that wasn't the final boss, but was good enough and simple enough and useful enough that it actually should have resources dedicated to it to actually build out that specific thing. And together, those things came together, and those were the seeds of Optimism itself being born.
Part of the thing that's happening here as well is you're an entrepreneur, you're a founder. And I've had the opportunity to speak with a lot of founders on the podcast. Talk to us about that experience. What were some of the key learnings that you had as an individual, as a founder in the Web3 space that might be useful for listeners that have ambition of doing the same?
Great question. I would say, I think the right answer to that is to talk about the mistakes. I think ultimately and I think this is the most true for the kind of technology solution that we're building, which is like highly technical. It's highly on the back end. What you need to do, and I actually heard these words when I spent time in VC. I had heard the words value proposition, minimum viable segment, minimum viable product. I'd heard those words thrown around a lot and had been in lots of conversations discussing the different attempts at answering those questions by different startups. But I would say that truthfully, only internalizing and making those mistakes ourselves was the way to actually learn those lessons. So to some extent, what I'm saying here is like, you can listen to what I'm about to say and try to internalize it and use that info. You will still make the same kinds of mistakes. Hopefully though, you'll make them, faster and correct them more quickly. So yeah, I would say the number one thing to understand is to have a really good grip on whatever you're building being taken to and like put in the hands of people that are using it that say, I like this. This is a good thing to have. So it's really easy. And I think Plasma was kind of a perfect example of this, right? Where, there is a world in which if the public goods funding problem was much easier to solve and we had been able to raise a bunch of grant money to go after building out this Plasma thing a year earlier in earnest, what we would have found was that we had built a much more scalable product than Roll-ups, but a completely broken product. Because what happened with Plasma was basically that you could not run EVM smart contracts. You could not run the EVM in one of these Plasma chains. It could use the EVM and be very EVM kind of like, but it ultimately didn't have the exact same properties. Like you could not take the Uniswap contracts and deploy them on a Plasma chain. And to be honest, it took like over a year for us to realize that was even a problem because we were just off like, oh my God, this technical solution is brilliant and it is going to solve the scalability problem that we're working on. Ultimately, I think what we would have found if we had taken that to market is that we would have been starting from square zero on all of the things that I was just talking about in terms of the tooling and the ability to develop on top. And like, it would have been even worse than the like kind of sketchy tutorials get outdated real darn fast state that Ethereum was in at the time. So yeah, I think that is my number one advice is like, once you have a good, basically building the technology is not enough. You need to understand and as quickly as possible learn and validate your hypothesis that that technology that you've described will actually be a useful thing that will solve the value proposition that you're trying to solve. That is the number one lesson. And, you know, I say that like we would have made this mistake a lot worse if we had built Plasma first. We still made that mistake, right? The first, year and a half of what we called the OVM, which was basically like the way that you could deploy Uniswap to a rollup like OP mainnet. Even that made a bunch of sacrifices and incompatibilities with the tooling that severely limited its ability to grow. And it was only once we said, okay, we need to revisit this. We cannot sacrifice the incredible developer experience and the incredible user experience that Ethereum has been building on towards years. It's just a non-starter to start from scratch. And basically what we were doing was not quite starting from scratch, but seriously breaking some of the tooling. Like you had to go in, for example, and replace the Solidity compiler with a different like Optimism Solidity compiler, OVM Solidity compiler. And as soon as you started getting there, you started losing massive numbers of developers because it was an incredible amount of work to just do that compiler change, especially with the state of tooling at the time. And that just introduced incompatibilities downstream towards all sorts of further tooling that, for example, assumed you didn't use a custom compiler and so on and so forth. So yeah, I guess all that to say, we didn't make the mistake with Plasma. That's an example of how we could have made it sooner. We still made that mistake in a lesser form. And it's just incredibly important to learn from that data as quickly as you can and make the adjustments that you should make based on it.
It's incredible insight, and I'm sure listeners will benefit greatly from it. And so I appreciate you taking the time there and just sharing that. And for me, as I listen to it, a light bulb moment of so many things that other founders have said on the podcast.
Well, like I said, certainly if you're getting serious into starting something, don't just listen to this podcast, and you will hear a lot of other resources saying the same things. And like I said, there's some extent where you have to learn the lesson yourself to really internalize it. But the faster you can do that and the smaller you can make those mistakes, the better off you're going to be.
Hey, what's going on, y'all? This is Ben Jones from the Optimism Foundation. Really enjoyed taking the time to chat on the GRTiQ podcast. And they wanted me to let you know that if it's been helpful to you too, then you should consider subscribing and supporting them. So if you go to grtiq.com/podcast, there'll be some info on how you can subscribe and help them out. So thanks so much again to the podcast for having me on, and thank you for listening.
Roger that.
Ben, one of the great things about this podcast in particular is there are a lot of non-technical people that use it as a springboard to get more active in Web3, more active in the graph. And so what I want to do, if you don't mind, is just real quickly provide kind of an intro explanation as to what Optimism is working on. We've said a lot of things here and you provided a lot of great background, but now we're at a point where we need to really talk about roll-ups and what they do, how they work, but also this question of like L2s. Are all L2s roll-ups? How does Optimism compete with or contrast with other L2s? Do you mind just breaking down kind of that universe, so to speak, of the things in the space you find yourself in?
Absolutely. I won't go too much into the description of the scalability problem. I think we kind of covered that earlier. But again, just to rehash, the problem statement is basically you can't just spin up a copy of a blockchain like you can spin up a copy of a single server somewhere on the Facebook backend, right? Because the way that these computational containers that blockchains are function and the whole value that they provide is being powered by a decentralized network, which is much more complex than updating the code on some server somewhere. So again, that's sort of the problem statement is how do we make blockchains be as big as possible or have as many blockchains as possible without the security and decentralization of them being fragmented across all of those different chains or just straight up losing it overall. So that's, again, just a quick recap on the problem statement. Okay, so then the question is, what is layer 2? The simplest way to think about layer 2 as an approach to scaling, and first of all, there are other approaches to scaling, but my heavily biased answer, is that layer 2s are the best, right? So the core insight into layer 2 is basically use blockchains more efficiently. And in particular, if you want a really simple analogy, I think the classic one is if you think of these, of Ethereum as like a decentralized court, right? Where it's like programmatically upheld. They just sort of the ultimate source of truth because of this decentralized consensus that powers it, right? Well, you don't go to court to cash a check. You go to court when the check bounces. And in general, using the block space, using these blockchains efficiently is what layer 2 is all about. And so basically, there are many different constructions and details that we can get into here. But at the core, basically all we're doing is saying, okay, let's make some sort of blockchain where its security is inherited from the security of the main chain of the layer 1. And that new blockchain will be called the layer 2. And because the layer 2 uses the layer 1 more efficiently, but still inherits the security and decentralization properties from that layer 1, this is how you solve the scalability problem.
And so talk to us about the universe of L2s then. So you're working on Optimism. You've told the origin story there and articulated it very well. But there's other L2s, like you said there, other approaches to this. How should we understand the ecosystem of L2s and what's going on here and what makes Optimism different?
Yeah, so great question. I think what you're getting at with that question is in some sense a taxonomy of L2s. So like, what are the different designs? How are other people approaching it? And there's a few different components to that. I think the simplest breakdown to give is that basically there are, and these naming conventions aren't universally shared, but they do capture, I think, most of what is going on in the scaling space today. It's basically a 2x2 grid. There's something called roll-ups. There's something called plasmas. There's optimistic proving, and there's ZK proving, validity proving. And that's this kind of like a 2x2 matrix where there's 4 different combinations of like the primary flavors of layer 2 scalability solutions, right? So roll-ups and plasma. This is why I said that plasma are coming back. There's a lot of different names for this since kind of plasma fell out of the popular grace. So one term you'll hear is of Iridium. You'll also hear ideas of alternate data availability roll-ups, which are actually, I would say, not a roll-up. They're a plasma by this definition I'm using. But anyway, those definitions aren't universally shared. But basically, there are 2 components that I'm talking about here. So one component is how transaction data is utilized. And so a roll-up, actually where the name roll-up comes from is basically like quote unquote rolling up of transactions to Ethereum. And so we were talking before about how do you more efficiently use the layer 1. In a roll-up, the way that you more efficiently use the layer 1 is basically that you post the data of transactions to the layer 1, but you do not execute them. It's almost like you're using layer 1 as like a notary service where layer 1 is basically signing off on the existence of some transactions. It's not doing anything else with those transactions, but it is signing off their existence. And so you get the decentralization properties of the L1 for basically like now anybody can go to that immutable, censorship resistant ledger and see at some point in the past, these were all the transactions for the layer 2 that were notarized. So this is a very important property of decentralization, because now you can basically always fetch the transaction data from the layer 1. And then you basically do an extra interpretation step. So you say, okay, all of these transactions on layer 1 were simply notarized and nothing was done with them. They weren't executed. They weren't validated. That made it much cheaper than if all those transactions were directly run on L1. But now I can take those transactions and interpret them as layer 2 transactions and do more with them. And the thing I do more with them, obviously, is like executing the sub blockchain, the layer 2 chain, and kind of running that software. So anyway, like I said, there's, one of these dimensions here is roll-up versus plasma. Roll-ups post all of the data directly to L1. That is extremely good for decentralization. It is also not infinitely scalable, or we might say not horizontally scalable in an unlimited capacity. And the reason for this is because even though it's much cheaper to use layer 1 for transactions, it still has some cost, and there's still only a certain amount of notarization, that the layer 1 can do. In the same way that there was only a certain number of transactions that Ethereum can do, if all of those transactions are notarization, then you can fit a lot more transactions in than you could before, but there's still some upper bound. So the other component, the other side of the roll-up coin is what I would call plasma. There's a lot of other names being thrown out. But basically the idea is, okay, the transaction data is in fact also not posted to Ethereum. Instead, what you can imagine is basically some sort of hash of the transaction or some small commitment or some small piece of the transaction is posted to Ethereum. But the actual data that underlying sort of all of the details of that is kept off chain. So one way to think about this, in the notarization example, maybe you imagine it like there is not a zip file, but kind of. Basically, you can imagine coming into and notarizing just the first and the last page in 1,000 pages, and having some like cryptographic way that says that pages 2 through 999 are indeed correct, or they've been like committed to as a part of the notary, but the notary didn't go and actually read all 1,000 pages, right? And so that is what we call plasma. So you basically keep the data off chain as well, and that gives you even more scalability, because now you can shove a lot of transactions, right? But if you move from 1,000 transactions to 10,000, well, the notary still only notarizes the first page and the 10,000th page. So it's the same amount of work. So you can fit kind of an infinite amount of data underneath that. So basically, that's the first kind of classification. There are things called roll-ups, and there are these things called plasmas or validiums or alt-VA chains that work in this other way that's a little less secure, because you have to go somewhere else to get the middle pages, right? You can get the first and last page, but then you have to use that to go fetch the other pages from somewhere else. But in return, you get kind of like infinite horizontal scalability. And then there's also roll-ups, where that is finite, but because every single page is notarized up front, then you get additional security guarantees. So that's one half of the 2x2, right? That is the plasma versus roll-up, which is like where the data lives, basically where transaction data is put. And the other dimension is proving. And so the question there is basically, how do chains communicate with one another is actually one way to say this, right? And zooming out, I think the useful thing to say is, you could build a chain exactly how I described, and do nothing else, and that would still be a valid chain. You could even call that a layer 2 chain. Sovereign roll-up might even be the term of the hour that others in the industry use to describe this. But the fundamental issue with that is that you basically are isolating that chain if there's not a way to prove the outcomes of those transactions, right? So we would basically be in a situation where, sure, you can run this node software. It downloads all the notarized data from Ethereum. It does this extra work that made it cheaper by not doing upfront of computing all the transactions based on those notarized pages, and then you arrive at a result. The question is, how can you use that chain? For example, can you take some ETH and move it into that chain, and then take ETH that was in that chain and move it back to layer 1 to do something on layer 1, or move it back to another roll-up that's running alongside it? And the core question there is basically, how do we prove things? How do we prove that the extra work that you do results in the following trusted thing? And furthermore, how do we do that while still maintaining the cost, right? So like, obviously the way that you could do this is just upfront, when every transaction is notarized, also execute the transaction on Ethereum, and then Ethereum will know what's up. But if you do that, then you're no more efficient than Ethereum. So you've failed to only go to court when the check bounces, right? So that's the problem statement for this other dynamic of the scalability taxonomy, is how is the results of these transactions proven, right? So first I talked about where do the transaction data go? And then this is, once you have that transaction data, how are the results of that transaction data shared with other chains, right? Because if you want to be able to withdraw your funds from an L2 to layer 1 Ethereum, layer 1 Ethereum needs to know whether or not that's your ETH, and it needs to know what address to send it to. And so it requires some sort of proof. So yeah, the main two taxonomies there in the current industry are basically ZK and optimistic. They're basically two approaches without getting too much lost in the sauce. Optimistic is the notion that basically anyone can come and propose what the result of those transactions would be, and then anybody else can come along and basically say, you are wrong, and let me prove it, and then subsequently cause those transactions to be played out on the L1, and basically discard if the result was invalid. So it's called optimistic because you basically allow anyone to say what the result is, and you basically say, if nobody says anything, then I assume that this is right. So the Ethereum is kind of, quote unquote, optimistic that result is correct. However, if the result is incorrect, there's a programmatic, trustless way for anybody else to come along and disprove that. So that's basically the core of how optimistic proof systems work. This is actually like the most direct, don't go to court if you cash a check, go to court if the check bounces, right? That dispute game that I was just talking about there, where if somebody said the wrong answer, you can go and challenge them. that is basically the equivalent of, hey, the check bounced. I'm going to go and correct this in the courts. So yeah, at a very high level, that's the optimistic scaling approach. And the other one is ZK. So basically, the other solution is that there are cryptographic constructions that use very sophisticated mathematics that basically allow you to prove the results of a bunch of transactions similar and using similar, it's like cryptographic, right? So it's similar to that, when you sign a transaction, that is kind of a proof that you have your seed phrase, your secret key material, without actually revealing that material. In the same way, there are very complex mathematical proofs that you can use to prove that the result of these notarized transactions, if you were to execute them, is X. And there's a way to actually prove X in a way that's cheaper than the overall cost of executing those transactions, but still has this kind of cryptographic promise. So there's a very rough 1,000-foot view that I'm sure there are lots of nuance that we missed in there of the different parts of the scaling landscape today.
Well, Ben, I'm sure that's one of the best explanations of L2s and everything that's going on here that listeners have been exposed to. And I'm certainly grateful that you took the time and explained it, an education and some brilliant insights there. So if we just do one more kind of zoom out, how do we make sense of all the different L2s then? I mean, is it just as simple as they're all taking different approaches, or are people competing with each other? And how should we make sense of the future of L2s? Is there going to be a proliferation of L2s, or will at some point there be some sort of standardization or consolidation?
Yeah, great question. So there's no question that it is more than just different teams are working on different points in that 2x2 quadrant or different points in the trade-off spectrum. And in fact, I don't even think Optimism is unique in exploring multiple points in that spectrum at once. I think we're probably the most aggressive in that we're moving forward both on optimistic proofs and ZK proofs. And we're trying to build basically the OP stack as a just general purpose. This is the best way to run a scalable blockchain and give developers as much choice as possible on where they want to sit on the trade-off spectrum. But, there are other people working on different data availability things as well. And there are other teams working on optimistic proofs. There are other teams working on ZK proofs. So that's definitely one dimension to it. From my perspective, that dimension isn't going to be the one that lasts. I think if you zoom out, the obvious place where this ends, especially when you consider things like open source, are that the most possible options are available to developers. And the differentiators are not rooted in the fundamental, point in that 2x2 grid that a particular project gives. I don't know if that's a universally held view, but that's certainly our standpoint. Obviously, there are other factors that come into it, right? Like developer experience is obviously one significant one that matters a lot, right? So right now, at least, different points on the spectrum do have different implications for developers. For example, on the ZK side, that moon math is a very, very difficult problem. So some of the ZK solutions, for example, do still require that you change the compiler in the way that I was describing that our early iterations did. I don't think that will last, but it is the case today. So there's also that consideration is what is the developer experience you're going to have. That extends both to the tooling that you use, but also the sort of integrations that are available. For example, what are the block like, can you go to an Etherscan for this L2, or do you have to use some other block explorer, so on and so forth. So there's a broader question of ecosystem and like developer tooling integrations. And then certainly, of course, the other component of it is the notion of what applications are present, right? So, you can, it may be the case, depending on what project that you're working on, that there are different pros and cons to different networks just based on the other applications that you want your users or that you want your application itself to be interfacing with as they do that. So that's a little bit on that. Your question was also like, where is this all headed? And certainly from our perspective, where it is all headed is one, guaranteed there will be a proliferation of chains. Like I said, this is basically like, you're just not bullish enough on crypto if you don't believe that's the case, because it's just not possible. Like we are going to have to see a bunch of chains if we're going to handle billions of people using this on a global scale. There's just no question about it. So that's easier to say in the abstract than it is to talk about specifics of, right? So I mean, maybe to talk about more of the specifics. From our perspective, what we're building out is something that we call the super chain, which is basically a emergent network of many chains that are unified by sharing a standard and are unified in terms of like their goal of forming one larger cohesive network. So like I said, there's going to have to be a ton of chains for any of this to work. And if you believe that we're going to reach global adoption, That has to happen. But the other thing is that all those chains should not, like users should not be under like some crazy situation where they are switching between chains every time they switch to a new application. All of those frictions that I talked about, the writing is on the wall that they're going to go away. And that's going to be a gradual process over time, right? It may start with, and well, it is already starting with wallets, for example, becoming sort of more chain aware and abstracting more of that away from the users. So, I think if you use wallets like Rainbow, for example, you get your balances displayed in aggregate across all of the networks that you have, all of the chains that you have, tokens or assets on. You don't just get whatever chain Rainbow is currently connected to, right? And so that trend is going to continue. For the application developers, that trend will continue, and basically in terms of messaging. So it will become easier and easier for you to build applications that use multiple chains on the back end and communicate with each other when necessary. Ultimately, what we're going to see is a crap ton of chains that are going to proliferate. There's no getting around that. But for us to really do that, there's also going to be a disappearance of chains where basically a chain is going to be as simple as a smart contract in the future. Like that is like the North Star of where like all of the Optimism superchain work is headed, is like deploying a chain should be as simple and interoperable as deploying a smart contract today.
And part of the reason you and I are talking today is, and you alluded this earlier when you were talking about tooling and the graph, is the graph is working very hard on providing support for Optimism on the decentralized network. Can you talk about why that's important and why developers on Optimism should be excited about this news?
Absolutely. Yeah. So, folks at the graph can do a much better job explaining the benefits of the graph than I can, but I certainly understand it as a benefit. I mean, basically what we're talking about here at the sort of data indexing layer that you guys are talking about is giving developers the tools to efficiently come to aggregate information or aggregate statistics about a chain. And this is super, super, super important, and really about a particular application. This is a super, super important thing to have, right? So if you're a developer, let's say that you want to display the cumulative trading volume on some application, right? What you shouldn't have to do is basically waste gas and actually like decrease the scalability of your application by tracking that in your smart contracts, if all you care about is displaying that to the users, right? That's an incredibly important thing. And so indexing services like the graph, and we're very excited to have decentralized support for the graph on Optimania now, is the key thing that we're doing here, right? Is basically allowing developers to expose aggregate data or like indexed data to the users without having to make blockchains basically like gas cost sacrifices to do that. So I'm probably preaching to the choir here. I'm sure that's been covered a lot, but yeah, that's super exciting. And again, one of the things that we must preserve as we go down the scalability path is the decentralization properties that we have from single chains, right? Like the problem statement here is preserve the decentralization of applications in a more scalable context. And so it's very exciting to have something like the graph as a decentralized network that's providing some of these indexing services, right? In terms of this aggregation that we were talking about. Because one of the failure modes that we have for crypto is effectively that there are large swaths of applications, of decentralized applications, that actually rely on highly centralized components to work, right? And so I understand that this is what the graph's decentralized network is doing for this indexing layer, right? So for example, it would suck if the application that we were just talking about, if the trading volume suddenly disappeared because one centralized actor that was running one, computer on some server somewhere went down or went out of business or was, subject to whatever centralized control. And that ends up bottlenecking the application and actually making the application non-functional for everyone, right? So there's a failure mode for crypto where basically sure, some of the core logic is in smart contracts and that part is decentralized. But realistically, the aggregate of all services and components and tools that are used to actually turn those smart contracts into an application front end that a user can interact with are actually much more centralized than the small piece of smart contracts. So that is an incredibly, incredibly important thing for us to have. I'm very excited to have the graph support because you guys are doing heroic work in making that happen.
if we think about the Web3 stack, and you've done such a great job today talking about how important L2s are as we think about this, when you think about that indexing and querying layer, I mean, it is table stakes necessary for Web3 to do what it wants to do, to have something like that.
Yeah, I mean, I'll just say yes, 100%. You know, like indexing is a very important thing, even in Web 2. It's just like one of the fundamental building blocks of applications, period, not just Web 3 applications, to be able to like basically efficiently cache and track data that is an aggregate of much larger amounts of data that you don't have to constantly go and recompute, right? So like this problem statement of like, oh, we want to calculate the total trading volume of all time, but that's not tracked in the smart contract. You have two options. Either every time you're requested for that information, you go back and through every single transaction that's ever happened and add up all the volumes together to get your answer every single time, or you have some sort of intermediary that's caching the current volume, and every time a new transaction comes along, it adds that to the cumulative and deletes it. That notion of like indexing and caching is not just for Web 3 scalability, but for Web 2 scalability, like a key stalwart building block. So yeah, 100%, super important.
So Ben, I only have one more question for you before we conclude with the GRTiQ 10. And those are 10 questions I ask each guest of the podcast every week to help shine a light more on the personal side of the guests and some of their interests and things they've learned through their own journey. And the question is, what should we be looking forward to in terms of the community at Optimism? What's coming down the road? What announcements, things are you working on? What can you share with us about that?
Oh man, yeah, so much. I think that the number one thing for us right now is the birth of the superchain and basically extending the software that we've written to run chains beyond just OP mainnet, right? So for many years, we ran a single chain ourselves. It's called OP mainnet. It's got a lot of traction. It's a great place to come and develop. But again, it is not the end game. We need to have many such chains if we're going to reach global demand. Right now, the Optimism community is at an incredible inflection point where the software is good enough and stable enough and easy enough to run. And the governance processes for how those chains, from our perspective, should be run and should interact with other chains, all of that groundwork has been laid. So, you know, I mean, recent very exciting news was that Base launched, right? Coinbase launched their own roll-up built on the OP stack and aiming to be a part of this aggregate superchain structure that we're laying out. So that's going to be 100%, I think, the most exciting thing to follow. Basically, a bunch of OP chains, is what we call them, are being spawned as we speak. Some are already out. There are lots more in the works. And that is extremely, extremely, extremely exciting. I think what we're going to see from that is basically the like proliferation of chains. And I'm very, very, very excited about that. There's going to be so much community activity. I'm I'm glued to the dashboards of all the other OP chains that are running and like seeing their successes and where things working. And I think that trend is just going to continue. So that is the number one most exciting thing. You know, we have a lot of exciting governance work as well. If you're like big into blockchain governance, go read the Law of Chains. This is like the proposed update to the Optimism Constitution that is basically addressing the multi-chain transition that I was just talking about from a perspective of what it means for governance and for the DAO and for our community. So that's super exciting. And I think if you're listening to this from the graph end, the way that you should hear that is get ready to integrate more OP chains because we're not stopping with OP mainnet.
Well, congratulations to you and the whole Optimism community. Obviously, the Coinbase Base release was a huge deal. It's incredible to see what they're doing and to know that it's all tied together with the work that you're doing at Optimism is incredible. I really appreciate you taking the time today to join me. As I said, I want to conclude with the GRTiQ 10. These are 10 questions I ask each guest of the podcast every week in hopes that listeners might learn something new, try something different, or achieve more. So, Ben, are you ready for the GRTiQ 10?
Appreciate you having me on too, and I am always ready, baby. Let's go.
The GRTiQ 10.
This is the way.
10 questions for astronauts floating in space.
This is the way. Roger that. This is the way.
What book or articles had the most impact on your life?
Ooh, I mean, you know, I'll start with the fiction, which is just like Harry Potter was such a massive influence on me as a kid. Zooming out beyond that, Gödel, Escher, Bach, if you want to learn about consciousness and AI and like what is these strange loops that give birth to, you know, our consciousness, that is an incredible book. It's dense. It is definitely on the nonfiction side, but it is very, very, very cool. So I have to shout that out. I don't know. I'll give another one, which is actually a little bit different. But for my personal history, my dad is like an inventor, tinkerer type. And so one of the communities that I really love that has just been exploding in activity is like the maker hacker community. This is actually the side of people like physically making things and physically creating things that solve problems. And yeah, so that's not a specific reference, but like, I just want to, I don't know, shout out to the maker community, because like, even over the past few years, like the number of YouTube channels and projects being built are just like exploding. And so I find that super exciting. It's a bit of a weird answer, but there you go.
Is there a movie or a TV show that you recommend everybody should watch?
Westworld. I watched it when it came out. The first season is like it probably is my favorite season of television. If you don't know, Westworld is this show about AI and like sort of like, are the computers conscious or not? And with all of the stuff about LLMs, which is like a whole nother rabbit hole that we did not get into, that is like very exciting. I just cannot strongly enough recommend Westworld. Like they predicted GPT years ago. It's actually shocking. I was expecting to rewatch it, which I did recently, and expecting it not to hold up in some of those fronts. But literally they understood next token prediction, like was how these AIs would come about like 6 years ago or whenever that came out. So watch Westworld.
If you could only listen to one music album for the rest of your life, which one would you choose?
Oh, if I can only have one, it would, I mean, it's a bit of a cliche answer. It might be Pink Floyd, Dark Side of the Moon. I'm a huge fan of Pink Floyd, and I know that's the even more cliche. I should be saying like Animals or something to be like, to sound cooler, but I just think Dark Side of the Moon is like the perfect album.
And how about this one? What's the best advice someone's ever given to you?
Oh man. I don't know if I can condense it down to one single, there's not like one interaction coming to my brain right now, but I would say that expectation setting has been one of the most important things for me to learn that extends like well beyond business. And it's funny, it's one of the aspects in my own personal life that I find to be most frequently repeated. And I find lessons that I learned in business to apply the most to my personal life. I think basically the core of it is like, as you're working on a relationship and working through towards some outcome or just like having that relationship, always understand that the things that you're saying now are setting their expectations and building their mental model for what the future is going to hold. And it's a very, very easy mistake to have where the exact same outcome upsets somebody because you've wrongly set their expectations earlier, even though in a vacuum, that outcome isn't bad or wouldn't necessarily be upsetting. So set expectations.
Number 5, what's one thing you've learned in your life that you don't think most other people have learned or know quite yet?
It might be that the AIs are coming. I think, I don't know how strictly like learned versus hypothesized, is like whether there's a good answer there is maybe debatable, but I mean, to speak to my personal history a bit, I talked about my experiences coding. I'm not a good programmer. I did it for a while in the early days of Optimism, but we were like fortunate enough to be able to hire much more competent engineers than I will ever be. What I will say is that early on, and my relationship with programming early on was always about side projects and just things that I enjoyed. And programming was so painful. And ChatGPT like literally transformed my life to where I'm working on coding side projects again, because I can work in any language, in any environment, and not spend 2 hours working through boilerplate. I can just immediately dig into the real thing that I want to do, right? Which is normally not accessible because you have to learn the syntax of the language and you have to learn the particular libraries that do particular things. And you have to go read an argument on Stack Overflow about how to correctly use these things and like find some code in there that you can copy and paste and Frankenstein into an answer. But the reality is with these LLMs, like the intelligence of machines is being burst. And like that, this is one way for me that like suddenly programming is back in my life outside of work because because the slog is now just like, tell ChatGPT to write me an answer and it will poop out some code that I can use and run with. Thing that I notice as I talk to many people outside of my, immediate like work bubble is that people have not realized yet the trajectory of these LLMs is going towards full intelligence. And the intelligence they have already is general enough and useful enough to be inserted into your everyday life. So I don't think people have fully internalized that like anything that is like you can input some text and the output would be useful to you can be done with ChatGPT at like a decent level now. And I use it every day in my life. And I don't think most people do. And I think if you're not, you're just at a disadvantage.
And how about this? What's the best life hack you've discovered for yourself?
Ooh, the best life hack. One is L-theanine. So L-theanine is like a drug or a supplement that exists in green tea. And it's the reason that drinking tea gives you a longer caffeine curve as opposed to one big spike with a bunch of jitters and then fall down. But you can buy L-theanine in pill form and basically take it alongside with your normal caffeine or your coffee or energy drink or whatever. And it will give you a much, much, much nicer experience that is not jittery and anxiety inducing, but is fun and enjoyable.
Based on your own life experiences and observations, what's the one habit or characteristic that you think best explains how or why people find success in life?
Yeah, I don't think it's obsession, but it's something like it. I don't think that any of this optimism stuff would have worked if like my co-founders and I weren't constantly thinking about all dynamics of it, like in the middle of the night, as we fall asleep, as we wake up. And I think there's something to be said there that is, I mean, there's some like work ethic element of that, but ultimately I think it's really most grounded in like your interest, where you're not like, you can't force something through to success if you're not to some extent genuinely interested in the problems that you're trying to solve. And like, I don't know, I find myself very, very motivated by the existence of a hard problem. Like if I learn about a hard problem, that I will start obsessing over it. And so I think to find success in these kinds of things, you have to be interested in truly interested and motivated to solve the problems and enjoy that problem solving process.
Okay, Ben, and the final three are complete the sentence type questions. Rapid fire, complete the sentence. The thing that most excites me about Web3 is?
Redefining the broken incentives of the world.
And how about this one? If you're on Twitter or X, you should be following?
At Ben_chain. That's me.
And the last one, I'm happiest when?
I'm happiest when we've solved a hard problem or when I'm making music.
The GRTiQ 10.
After this, I show you how deep the
Podcast.
This has been a production of the GRTiQ podcast. For more information, including detailed show notes, visit grtiq.com/podcast. That's grtiq.com/podcast.
Please consider contributing to this project and helping build the community by subscribing and leaving a review. GRTiQ Podcast.